Hi guys, welcome to the first part of chapter 3. This is going to be a really quick chapter. Okay, so this is going to be 3.1 notes. So we're going to start off with what parallel lines, parallel planes, and skew lines are. Alright, so let's start with parallel lines. Parallel lines are coplanar lines that never intersect. Okay, we're going to use arrows to indicate that these are parallel. So if we look over here, these are those arrows they're talking about. You'll see arrows on each line, and that means that those lines are parallel. Now, just like how we had before, if we have different parallel lines here, so say I made these two lines that are also parallel, those black lines would be the first parallel lines. Now these ones are going to be the second parallel line, so I'm going to add 2 arrows to those. So keep those in mind and be careful as you're looking at which ones are parallel. They're denoted with those arrows. We use the symbolic notation of 2 parallel lines to denote that things are parallel. So using our example off to the side, line AB is parallel to line CD. Again, just 2 parallel lines straight up and down. Next, we're talking about parallel planes. Parallel planes are planes that, again, never intersect. We're going to use the same symbolic notation here to denote that our planes are parallel. The next one we're going to talk about is skew lines. Now, skew lines are going to be non-coplanar lines that never intersect. So parallel are ones that are coplanar, same plane, that never intersect. Skew lines are non-coplanar lines that never intersect. So let's talk some examples over here with our handy-dandy box. So some examples of skew lines. I'm going to use TP here. Let's see, let me get a little, there we go. Oh boy, that's big. Let me try that again. Let's do that. That looks good. All right, so here's TP. A line that would be skewed to TP is one that is not on that same plane, but is also never going to touch it. So an example of that would be UV. So let's write that down. TP, the segment, is going to be skew to UV. Okay, see if you can identify some more. I'm going to go ahead and write some more examples. So another one that would be skew would be TW. TW can be skew to UQ. All right, let's do another one here. Let's do PQ. Let's do that bottom one. So here's PQ. A line that is skewed to PQ, in other words, will never touch and is non-coplanar, would be SW. Beautiful. All right, let's look at our first couple of examples here. So they want us to name all segments parallel to AE. Right here is AE. Okay, and they want a segment that is parallel to that. Well, a segment that is going to be parallel to that is going to be HD. Oops. Another segment that is going to be parallel to that is going to be GC. And finally, the last one would be FB. Now they want us to give 2 examples of parallel planes. I'm going to do this first front plane here. Okay, so that plane is going to be plane EAB. So that front plane, or think like the front of your cereal box, is going to be parallel to that back plane. The back plane is going to be HGC. All right, let's find another one. So let's do the sides here. So there's one plane. So I'm going to call that plane FBC. Remember, we need 3 points to name a plane. So that would be the side of my cereal box. The other side is the side that would be parallel. So that would be right here. So that would be plane EHD. All right, last part of this question is they want us to name all segments skew to GH. So let's find out here where GH is. GH is right here, this back line. Okay, so we want everything skew to that. So one thing that's going to be skew is going to be FB right here. Another skew one is going to be AE right there. Another skew will be this BC. And finally, AD. So let's write all those down. We have FB. We have EA. We also said BC. And finally, AD. All right, let's move on to example number 2. So they want us to name all segments parallel to JK. Here's JK, it's a bottom line right there. A segment parallel to that is going to be OP, that back segment. Next, they want us to name a segment that is parallel to NS. NS is one of these side connectors here. So all of those side connectors will be parallel. So we're going to have JO going counterclockwise here. We're going to have KP. We're going to have LQ. And lastly, MR. All right. They want us to name a plane parallel to JKL. JKL is this front pentagon. The plane parallel to that is going to be the back pentagon. And we're going to call that plane. And then pick any 3 letters on that plane. I'm going to go with QPO. Next, they want us to name 4 segments skew to RQ. RQ is right here. So we need things that are non-coplanar and will never touch. So we can do LK. We can also do NJ. We can do JO. And lastly, KP. Those are all lines that will never touch and are non-coplanar. So let me highlight those. There's LK, NJ, we have JO, and KP. You could have also done LM, could have done NM, could have done NS. All right. You could not do MR or LQ because those do touch and intersect. Transversal. Transversal is a line that intersects 2 or more lines. So here you'll see my 2 lines are L and M. And my transversal is going to be this T. It intersects those 2 lines. Now, when we have transversals, we have some special names that we can give certain angles within these transversals. So, let me highlight in purple some corresponding angles. So corresponding angles would be like angle 2 and 6. We could also do 1 and 5. Another corresponding angle would be 3 and 7. And finally, 4 and 8. Corresponding angles are going to be angles that are in the same spot on the different transversal intersections. So for example, 1 and 5, here's one transversal intersection, here's another transversal intersection. 1 and 5 are both on the top left hand side. 2 and 6 are both on the top right hand side. 3 and 7 are on the bottom right hand side. And 4 and 8 are on the bottom left hand side. So they're all on that same spot of the transversal intersections. All right, let's go over now what we are going to be talking about for alternate interior angles. Okay, so let's give some examples first. Alternate interior angles are going to be 4 and 6. Another pair of alternate interior angles is 3 and 5. So alternate interior angles depict angles that are on the inside of our two lines that are cut. So that's the interior portion. And alternating means that they are on alternating sides of that transversal. So 4 and 6 are both on the inside, but they're on opposite sides of your transversal. Same with 3 and 5, both inside but on that alternating sides of your transversal. I'm going to give you a minute to kind of copy down these right here. And then we'll get started with alternate exterior angles. All right, alternate exterior angles are essentially the opposite of what we just talked about with alternate interior angles. So some examples of alternate exterior angles are going to be 2 and 8 and 1 and 7. Again, they are on alternating sides of my transversal, but they are on the outside this time of my lines. Next, we're going to be talking about consecutive interior angles. We also call these same side interior angles, you'll hear. All right, consecutive interior angles are going to be examples like 4 and 5. Another example is going to be 3 and 6. They are consecutive, meaning right on top of each other, but they are on the inside of those lines cut by the transversal. And again, you can see why they call them same side interior. Okay, another last one is going to be consecutive exterior. So again, same idea as our consecutive interior, but these are now on the exterior. So 2 and 7 are consecutive exterior angles. And then 1 and 8 are consecutive exterior angles. Again, same side of the transversal, either both on the inside or both on the outside. All right, so here's some practice that I would like you to try. 3 and 4. So all you're going to be doing is you're going to be looking at the diagram that they have next to each other, and you're going to be looking at the two angle numbers. Are those angles consecutive interior, consecutive exterior? Are they same side interior, same side exterior, or maybe they're corresponding? You're going to write that name in the blank next to it. If they are none of these, you're just going to write none. So I'm going to give you a minute here, pause the video, give these a try, and I'll give you the answers. All right, hopefully you've given these a try, and let's see if our answers match each other. So really quickly, let's go over this first one. 1 and 8, here's 1, and here's 8. Those are on alternating sides of my transversal R, but they're both in the exterior. The next one would be 2 and 3. 2 and 3 are on the same side of the transversal, but both inside. So we call that our consecutive interior. 5 and 7 are both on the bottom left-hand side of our intersection points. So those would be corresponding angles. 2 and 7 are on opposite sides of our transversal, but both on the inside of those two lines. So those are what we call alternate interior. 1 and 3, again, are both on the top left-hand side, so those are corresponding. And the last one is 5 and 8. 5 and 8 are on the same side of that transversal, but both on the exterior. So those are consecutive exteriors. All right, that is all that we have for today. If you've got any questions, please let me know. And let's set up a Zoom if you want to.